will start to talk about transformers. Transformers are kind of device that use to either increase or decrease the alternating voltages, right? So there are two types of transformers, step up and step down transformers, and here we will see how they are working. So they are working generally on the principle of mutual inductance. We have already learned about that. So here we will see how the mutual inductance, using the principle of mutual inductance, how the transformers are working. So before that, let's see what is the construction of a transformer. So generally a transformer is a kind of frame which has the wiring in both of its side, and one of them are taken to be the primary coil, and another one would be the secondary coil. So here we have these two coils. So this what we have called it as primary coil, and this what we have called it as the secondary coil. So let's suppose the primary coil has the number of turn as NP, and it is being given to a voltage Vp at the initial stage. So it is being given an alternating voltage of Vp, and since it has a turn Np, then there would be a flux generated due to this. There would be an induced flux, and this flux would be generated in the secondary coil. The flux, let it be phi, which is generating at a time t. So we know that EMF produced in the secondary coil due to the primary coil voltage would be ES is minus NS d phi by dt, right? So this is the NS is the number of turns or number of turns in the coil of the secondary coil, and d phi by dt is the rate of change of the flux. So this is the EMF produced in the secondary coil, and this in turn would produce a back EMF in the primary coil, which would be given as EP, which is equal to NP d phi by dt minus NP, where NP is the number of turns in the primary coil, right? So the primary coil produces a EMF in the secondary coil due to the flux phi, which has a back EMF produced in the primary coil, is given by EP. Now as we know that EP and the given voltage to the primary coil Vp would be same. So therefore Vp will be equal to epsilon P, and Vs would be equal to epsilon S. And if we just substitute, we will get this equal to minus of Np d phi by dt, where this is equal to minus of Ns d phi by dt. Then if I just take a ratio of secondary to primary, secondary voltage to primary voltage, this is nothing but Ns by Np, right? So what we get, the ratio of the voltages is equal to the number of turns of the coil. Now let's suppose there are no power loss. Though we'll talk about the power losses, there are power losses in the transformer. We'll talk about the various power losses in the next classes, but here we are assuming that there are no power loss. So let's talk about power. Power is V into I, that is voltage into the current. So if I take the current in the primary coil to be IP and in the secondary coil to IS, then I can say primary coil has the power as Vp into Ip, and secondary coil has power as Vs into Is. So if there is no power loss, then primary and secondary, the total power would remain the same. So therefore Vp into Ip would be Vs into Is. Then what we see from here, Vs by Vp would be actually IP by IS, which is nothing but NS by NP, right? So in other way, what we can say that the current IP by IS is Vs by Vp, which is nothing but Ns by Np. So finally the discussion boils down that the number of turns is very important. So the voltage and the current in so as well as the power, if there is no power loss, so this ratio actually depends on the number of turns of these coils. Now suppose if Ns is greater than Np, that is the secondary coil turns is more than the primary coil, then what happens? Then Vs becomes greater than Vp. It means the voltage produced at the secondary coil would be more than the voltage applied at the primary coil. So this is the voltage applied and this is the voltage that we are getting at the secondary part of the coil, right? So if the outcome, that is the secondary coil voltage is more than the primary coil, then we call this type of transformer as step up transformer, because it is stepping up. The secondary has more voltage than primary, so this is called step up transformer. And if Np is greater than Ns, then Vp would be greater than Vs, then we call it as step down transformer. So what we see, using this we can either increase or we can decrease, either step up or step down the voltages of this particular device. So that's how transformers are very important. So here what is important? The number of turns are very important. So the ratio of Ns divided by Np, so this ratio is one of the most important thing that we call it as K. The ratio of the we can take it as Np or just we will keep it as the same thing. So Ns by Np, this ratio we will keep. So this is called the turn ratio as K. So if you see, if Ns is greater than Np, right, then we call it as step up transformer. It means that if K is greater than 1, we call it as step up transformer, where the turn ratio is greater than 1. And if the turn ratio is less than 1, that is if Np is greater than Ns, that is Ns is less than Np, then we call it as step down transformer, where K is less than 1, right? And finally, coming to the efficiency of the transformer. Efficiency is the output power of the transformer divided by the input power of the transformer. So generally this output power of the transformer means you can just take it as Is into Vs divided by Ip into Vp, right? So the output power and the input power, this ratio is called the efficiency. So here in this case we have taken the power to be same in both cases, but generally in that case the ratio will be 1, means efficiency would be 100%, but generally that doesn't happen. Why? We see there are this doesn't happen, efficiency is never 100%, so it means the output is always less than the input due to certain power losses, due to there are certain loss of power in the whole transformer. So we will see what are the power losses in the transformer in the next video.
If you like the video, then press the like button, subscribe to the channel and press the bell icon.